Hi everyone. So today I'm going to go through a paired or dependent t-test. I've already done a video on the unpaired or independent t-test, so you can check that one out. This one's slightly different, so I've done them in two separate videos. And then from this I'll move on to the ANOVAs in subsequent videos. But I'm going to follow the same procedure as I did before, so just running through some of the core assumptions and when you'd use the test and then how you'd run it in SPSS. So typically you'd use this when you have samples that are essentially related to one another. So the best example for this would be if you take a measurement from the same group of people over time rather than from two different groups of people at the same time. In that latter case, you'd run an independent t-test rather than a paired t-test. And it has one major assumption, although there might be another one, but this is the major one, which is the same as the independent t-test, which is that the data follows a normal distribution. That is, the data is parametric, and you can check that, and we'll go through that. And then if it's not, you can run the non-parametric equivalent, which is the Wilcoxon signed rank test. As before, the sample size may be a factor. If you've got quite a lot of people in your group, then you may not have to worry about using a non-parametric test. Some people just run the paired t-test anyway, but typically with smaller sample sizes, you may need to change. So let's just look at an example. It's the same example I gave in the other video. It's just changed slightly, but it's the same data. So here we've got 3 people in a group. So this is a very small sample size. And then you take resting heart rate from them on 2 separate days. So here we've got day 1 and we've got day 2, and there might have been an intervention somewhere, but typically there might be a change that you're interested in determining to see if there's a significant difference. So here it goes up from 49 to almost 86. So yeah, the main features here are 3 people per group and 2 time points. So these data are essentially dependent on one another. It's the same people measured over time, not 2 different groups of people. And then if you plot it, we can see that there's a difference, but we want to know if it's significantly different. We've only got 2 groups, so this is a t-test. If you had more than 2 groups, you could either run multiple t-tests or you could run an ANOVA. That's something I'll go through in another video. But first we want to see if we can check normality. So just the typical flow that I'd use, I'd check normal distribution first. You can use a Shapiro-Wilk test for this, which we'll go through. And then depending on what we find, we can either just run the paired t-test or change to the Wilcoxon rank test. I'll run them both anyway, just so we can see how we go through both of them. All right, so I'll show you how to set the data up in SPSS first as well. So this is our data, the exact same data here, but that's for the unpaired t-test where we have 2 different groups. Here we've got 2 separate days, but it's the same group. So we can go into SPSS. So to do this, we need to set up 2 scale variables. So we can call this whatever you want, but it's 2 scale variables, whereas for the independent t-test, you'd need to set up a nominal variable and name your groups. Here we don't have to do that. So we can call this heart rate 1 for heart rate group 1, and then heart rate 2 for heart rate group 2. You can't have any spaces here, and you can set these to scale. It'll do this automatically to scale if you don't define them. And that's really it. And now we can just copy and paste our data from Excel. So if we take day 1, just copy and paste that across. Yeah. So we do that again. Just do it both at the same time. Okay, fine. And now we can see that it's right. So we first need to run the normal distribution test. So this is analyze, descriptive statistics, explore. And we put them both in the dependent list box. If we had a nominal variable, that would go in the factor list box, but we don't. So we put them both there. And then for our plots, you can choose whatever you want here. I'm just going for what I want, which is normality plots with tests. And then we click OK. So this will tell us if our data is normally distributed. So this is the box we look for typically. This is what has our p-values. We want the Shapiro-Wilk. This deals with normality with smaller sample sizes. The Smirnov test is typically for much larger sample sizes, so we don't get an output here. So we're looking for higher than 0.05, so both of these groups, well, not groups, but the same group measured over time, both of these have higher than 0.05, so our data is normally distributed. If they were lower than 0.05, this is where you might consider using the Wilcoxon test, or you could log transform the data, see if that fixes the issue of normality, and then run the normality test again. You do have reference here for your QQ plots to check for any outliers, but ours doesn't seem to have that issue. So all good, we can seem to run the t-test, so we can do it from this window, we don't have to go back. So for this, we can go analyze, compare means, and we have paired samples t-test. If we run an independent t-test, we'd go here, but we want paired. All right, so heart rate 1 goes in, heart rate 2 goes in. We can check on options, we're not interested, we don't want to bootstrap, and we can just click OK. All right. So here we get some descriptive statistics. So it gives us our mean, our standard deviation, number of replicates within each group. We've got 3 people in each group. Our standard error of the mean, which is typically always smaller than our standard deviation. And what we've got here is the main output, which is the difference between the two. So here we've basically got a mean difference of 36 beats per minute, and then standard deviation, standard error of the mean difference. And basically what we've got is a significant difference whether we run it as a one-tail test. So if it either just goes up or just goes down, or a two-tail test, which is typically twice as big as the one-tail test, because we're assuming it could go up or down. So typically run a two-sided test, but this is saying it is significantly different. So the data is normally distributed. That mean difference in heart rate of 36 beats per minute is different. Let's say it wasn't normally distributed and we wanted to run the other test, we can do that. So for the Wilcoxon test, it's a non-parametric test. So we go to analyze, and then we go, where do we go? Non-parametric test, related samples. If it was an independent t-test, non-parametric alternative, we'd go to independent samples, but we want related samples. Here we can go fields, and then we've got our heart rate 1 and heart rate 2. We can just move those over into the test field box, and then we can go to settings, customize. In here you've got Wilcoxon. You can just click this, and then we can run, and we'll get our output. So basically here it's given us our non-parametric output, and it's said that it's basing this on the median and not necessarily the mean, but it's telling us that it's not significantly different, so we need to retain the null hypothesis. 0.109, so that's higher than 0.05, so it isn't different. But we don't really need this because our data was already normally distributed. So that mean difference did come back as significant, but if you ever need to run this test, you can see how it's done there. All right, so that's the last video I'm going to do on t-test. The next one, I'll go into the different types of ANOVAs, like one-way, two-way, three-way, and maybe even a four-way, and all the different combinations therein. But if you found this video useful, please hit the like button and subscribe for more videos. Okay, thanks for listening all. Bye.